Hi, so I'm following along with Paul McWhorter's Fusion 360 slash 3D printing videos, and um, mainly doing it to refresher and get some teaching tips and everything like that, as I've been using Fusion 360 and 3D printing for many years. Um, this video is about just recently somebody that knows that I like coding gave me a book called Mazes for Programmers. Now, they gave me a book, but they didn't really know what kind of programming I did or anything like that. And the mazes in here are actually coded in Ruby, and I didn't know what Ruby was and don't have a program on my computer to write Ruby programs or to use them or anything like that. So that part of it wasn't too useful. But the book has 12 algorithms that they're just ways of doing it, and you could turn them into whatever kind of code. You can port them to Python or C++ or whatever you want. And it was very interesting reading about the different ways to generate random mazes, and they even have some maze solving algorithms in here as well. So it was a good gift and everything, but I just probably I do audio books now and get all my information off the internet. So this is probably the first book that I've read cover to cover in probably 2-3 years. So it was worthwhile, and I got a lot out of it, even though I can follow along with all programming language have similar loops and conditionals and stuff like that. So it wasn't that hard to follow along. Just had to figure out what syntax they were using. But while I was doing it, it brought back memories back in 2016. I've been doing library classes, tech library classes for teenagers for many years. I think I didn't start much before that. Maybe in 14 I started with them, and I'm teaching them Arduino and 3D printing and robotics and a lot of different things. And in 2016 we actually had a nice core group of 6 to 8 teenagers and preteens that came into class quite often, and they were very gung-ho, and we completed a lot of projects and everything. And back then Instructables was a big thing. So we actually, a couple of them wanted to do Instructables, so we took some classes to learn how to actually document our projects and write them up for Instructables. And we ended up with 2 of them. One was for this walking robot that we have. We called it the IC Bob. My club was called the aMAZEing Club, so that's where the IC comes from. And Bob, there's a lot of Bob robots out there. Most of them are like square with feet or whatever, but I think it stands for bipedal something robot or something. I don't know, biped robot, but I don't know what it is. But this was our take on that, and uses 4 servos and Arduino clone on there. It's actually one that I forget the brand, but it was an off brand, but it had a lot of extra pins and a extra power and everything. It looked more like I don't know, a nano expansion board, where you could plug your servos right into it, so you didn't have to do any wiring or anything. But to get back to my story today, we also did this one where we have a maze that's controlled by an Android device, and it sends it over classic Bluetooth to Arduino to pan and tilt this maze, and you can use the Android pan and tilt uh, accelerometer or whatever's in there, gyro, to um, uh, move the maze wirelessly. So that was kind of cool. It wasn't perfect because you get some jitter in your with those cheap. They would just use them 9G servos, and they have some jitter in them when you get them just in the wrong position. So it didn't work out perfect, but it did do okay. So click on this. We did, between myself and the teams, we wrote up a lot of stuff. Like I say, we used MIT App Inventor 2. I don't even know if that's still around. I guess so, but we listed all our resources and everything, and took lots of nice photos. This is a photo of all the parts. We had a camera bug in our group, and they took pictures and label that we went into a graphics program and painted all, I mean, not painted, labeled all the parts and everything. So that was kind of cool. I guess there was actually only two. Well, this was a different project, 2 servos in it, but in the base and everything. And anyhow, like I said, the story was, I'm going to actually recommend maybe for you guys to not to make this project, because I don't even know whether you can even make this or not anymore. I don't know whether, like I say, Android has probably moved on since 2016, so I don't even know if it will work, the software and everything that's in here. But it worked back then anyhow. So, but the thing was, is that while we were trying to figure out how to do our mazes, and we actually went on Thingiverse, and there was one of the students found this 3D maze generator that works with Blender, the Blender program, and it's actually a Python script that generates the random mazes. And at that point, we didn't know anything about Blender or anything. Actually, let's see if we can go back and we see. No, let's see. Sorry about flipping through here, but yeah, you can see this is actually the CAD program that we were using back then. It wasn't, this was pre-Fusion 360. We had a program called, what was it called? I forget, but something mechanical anyhow. And it made, it was a 3D program similar to Fusion 360, but definitely didn't have the parameters, and you didn't have your timeline where you could go back and change something. Once you made it, it was done, and you couldn't go back and adjust things and everything. So it's certainly wasn't anywhere near. It was called Design Spark Mechanical. I finally remembered the name. So anyhow, yeah. But anyhow, getting back to the mazes, I think the mazes, I never recommend people just going on Thingiverse and downloading something and printing, but I am going to suggest that you do that today. Like I said, when we were doing it back then, we had this Python script for Blender, which is what we used. And when I was looking back at it, we had it linked to it here, and I can go right to the page. And this guy had it, and it was got the files. You can go to the thing files, and somewhere down here, he's got the blend maze generator thing that you have to do. And I think there's instructions for it as well. I guess the Python is what it is, but anyhow, that's what we used back then, and I can't remember even how to do it. And my computer that I have now actually doesn't even have Blender on it. I think I only loaded Blender just because back then, and I said for this purpose, because it seemed like it was too much of a struggle with the back then, at least with the instructions for how to get it to do what you wanted it to do. So I really didn't do much with it and have never done much with it. But anyhow, I was revisiting them today and I found that he had updated it after we had been on there. And there is actually open SCAD version of this. That's open SCAD is a programming 3D language and program that creates 3D objects. It works it has some similarities to VPython, if you've been doing Paul's thing where you create objects, cylinders and rectangles and different things you can create out of it, spheres and stuff. And that's what you use to create your 3D objects. And but this guy actually used it, and because it's all pure code, there's no mouse involved with it. You design parts in code only. So so there was a link to this, guys, and so I went to that, and he has it there, and he had a link to the OpenSCAD code to generate these mazes. And I said, well, I had played with OpenSCAD 4 or 5 years ago, and I got through all the basics and did a lot of tutorials, but it wasn't very functional for me as far as, once you get past the basics of it. It was all code, and you could almost do more with building blocks in Tinkercad than you could in this. It was something that it was interesting to learn, and but I went on, forgot about it, but it was still on, actually it was the same computer, so it was still on this computer here. So I was able to just download that and try it out. So I don't know what the Blender product, whether it still works after 6 or 7 years, but even after 6 or 7 years, this was back in 16 when this was 15 or 16 when this was posted on Thingiverse. And I was able to just download it and open the code in the editor, and you're able to just it's a C-like language. You got the semicolons at the ends of statements, and let's see what else we got. Got functions and stuff like that. You got for loops. They actually work a little bit different. For loops are working a little bit different, but everything's got if statements and for loops, and so all languages are about the same, but it's got similar syntax to C++, but it's its own custom language for sure. But I revisited some of the few tutorials on this OpenSCAD and said, oh yeah, I remember how this works now. And I actually tried to go through this program and figure it out. And how many lines is it? It's only 230 lines, but I really couldn't follow it all the way. I know exactly what he's doing from my maze book. He's doing the what they call the reverse backtracker algorithm is what he's doing, and it creates nice mazes that are very random and everything. So it's kind of cool. But you have these parameters in here. You put how many rows and how many columns, and you want the wall thicknesses. They all recommend that you do multiples of your nozzle diameter. So this is only going to give you 2 walls when you're drawing this. And I found that to be fairly good as far as what you want to use. And then this is all in millimeters. So the wall height is 6 millimeters, and the width of the uh, passages is 7 millimeters. The reason that this is actually the way it came, but the reason that it probably is because myself and a lot of others tend to use 1/4-inch ball bearings. I got it in my hand here, 1/4-inch ball bearings in the mazes. And I actually went and found all that projects in a box in my garage for that whole maze thing. I don't think I'll ever open it back up. I don't have an Android device. I switched over to all Apple devices as far as phones and stuff now, and don't have a tablet or anything. So probably not going to do that project myself either. But I did find where I had practiced making mazes, and I got handful of mazes here, all random and different sizes even, and everything. So I think it for somebody looking for something to 3D print that is customizable and pretty easy to print. If you can get something flat to print, then if you got warpage coming in for the base has got to be all single, one layer. Sometimes you get a little bit of warpage with that, but that's a good test for your printer if you make them too big. But anyhow, like I said, you got, you can adjust these things for whatever size you want, and you can create it and save it as an STL and send it to your slicer. But you can do this preview here, and should be different every time. I don't know. Let me close myself here. Well, you all can see it, I guess, and I can move it around a little bit. But you should be able to, every time you click this generate button here, it's going to give you a different maze. So, and if you decide you want to make it a different size, so let's make a 10 by 10 maze. And then you're going to generate it. And now you're 10 by 10. And these all have a way to get out of them. Follow it around. I'm blocked in here, but I imagine you're going to get out. So this algorithm gives you a one path from beginning to end, and that's kind of cool. So if you don't want to do a lot of your own designing, you're not waiting for Paul to get around to teaching you more about Fusion 360, and you want to put your 3D printer to work, this isn't a bad way to go. Like I say, I'm going to leave links to the Thingiverse and probably the OpenSCAD. I'll put both Thingiverse things in there, and OpenSCAD. If y'all want to find Blender, you can do that on your own. This is more along the lines of what we've been learning in Paul's classes anyhow. So maybe other people can figure out what they're actually doing in there. But it's a pretty intense programming that this guy did. So like I say, I can get the gist of what they're doing, but what they're actually doing is they're drawing individual rectangles, and you can draw this. It's sort of like you can draw all this in like 2D, like sketches, but they're like rectangles. They're not lines, they're rectangles. And then once you have them all designed and all your spaces and all that, then you just extrude them, whatever your height of your wall height is, and it extrudes them all with one line of code. But you got to figure out where you want them and how the code figures it all out. But yeah, so I'm gonna make another one here. That's how fast you can make all the mazes you want, different sizes and everything. I'd suggest starting with something maybe 8 by 8, 10 by 10 to start with, and they really make nice something that you can give to kids or something, or to show off what you can do with your 3D printer. You can make that's why I ended up with 3 of them all in one right after the other. They're so easy to make that you just get these files and let your printer go at it. So, but like I said, the big thing is you want your wall thickness to be 2 times your nozzle. So if you got a 0.4 nozzle, yeah, that's what you want. So I rarely, if ever, suggest printing things off a Thingiverse, but this is a exception because it's customizable and you can learn a little bit about code and a different program, a different way to draw stuff. You can try a couple tutorials on the OpenSCAD and you'll see, oh wow, I think I'll go back to Fusion 360. It's a lot easier. Anyhow, that's what I got for today, and just wanted to share that with you. Talk to you later.